The National Electrical Code, or NEC, provides specific guidelines for electrical installations to ensure safety and proper functionality. One important aspect of electrical work is the grounding system, which provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. In residential electrical work, the NEC prohibits twisting bare ground wires together as a means of making a connection. This practice is not considered a reliable or safe method for ensuring a proper ground connection. Instead, the NEC requires that ground wires be connected using approved methods that provide a secure and permanent connection. There are several approved methods for connecting ground wires, ensuring a safe and effective grounding system. Firstly, pressure connectors, commonly known as wire nuts, are a widely used method for connecting ground wires. When using wire nuts for grounding connections, it is crucial to select wire nuts that are specifically marked for grounding use. These wire nuts are typically green in color or have a green stripe, indicating their suitability for grounding applications. The marking ensures that the wire nut has been tested and approved for providing a reliable connection for grounding conductors. To properly install a wire nut, the ground wire should be stripped to the appropriate length as indicated on the wire nut packaging. The stripped ends of the wires should then be held together parallel to each other, and the wire nut should be twisted onto the wires until it is securely tightened. It is important to ensure that the wire nut is making good contact with all of the wires and that no bare conductor is exposed outside of the wire nut. Secondly, crimp connectors are another approved method for connecting ground wires. Crimp connectors provide a mechanical connection between the wires, creating a secure and permanent bond. To use crimp connectors, the ground wire should be stripped to the appropriate length as specified by the connector manufacturer. The stripped ends of the wires are then inserted into the crimp connector, and a crimping tool is used to compress the connector, creating a tight and secure connection. It is important to use the correct crimping tool and die for the specific type and size of crimp connector being used to ensure a proper connection. Thirdly, listed mechanical splices are also permitted for connecting ground wires. Mechanical splices are devices that use screws or other mechanical means to clamp the wires together, providing a secure electrical connection. When using mechanical splices, it is important to follow the manufacturer's instructions for installation and to ensure that the splice is properly tightened to provide a reliable connection. These splices must be listed, meaning they have been tested and approved by a recognized testing laboratory for use in grounding applications. The listing ensures that the splice meets the required safety standards and performance criteria for grounding connections. In addition to using approved methods for connecting ground wires, it is also important to ensure that the grounding system is properly installed and maintained. This includes ensuring that all grounding conductors are properly sized, that all connections are tight and secure, and that the grounding system is regularly inspected for any signs of damage or deterioration. Proper grounding is essential for electrical safety, and any deficiencies in the grounding system should be addressed promptly to prevent electrical shock hazards. Grounding electrode conductors connect the grounding system to the earth, providing a path for fault current to dissipate into the ground. These conductors must be properly sized and installed according to the NEC to ensure that they can effectively carry fault current. Grounding electrodes, such as ground rods or ground plates, are used to establish a connection to the earth. These electrodes must be installed in accordance with the NEC requirements, including minimum depth and spacing requirements. Bonding is another important aspect of the grounding system. Bonding refers to the connection of metal parts of the electrical system, such as metal conduits, enclosures, and equipment, to the grounding system. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Equipment grounding conductors provide a path for fault current to return to the source from electrical equipment. These conductors must be properly sized and installed to ensure that they can effectively carry fault current and protect equipment from damage. In summary, the NEC prohibits twisting bare ground wires together in residential electrical work. Instead, ground wires must be connected using approved methods such as pressure connectors, crimp connectors, or listed mechanical splices. It is important to select connectors and splices that are specifically marked or listed for grounding use and to follow the manufacturer's instructions for installation. Proper grounding is essential for electrical safety, and any deficiencies in the grounding system should be addressed promptly to prevent electrical shock hazards. Always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with the NEC. The information provided here is for general knowledge and informational purposes only, and does not constitute professional advice. Always consult with a qualified professional for any specific questions or concerns about electrical installations or the NEC. The NEC is a comprehensive set of standards that covers a wide range of electrical topics. It is important to stay up to date with the latest edition of the NEC and to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the code. Proper grounding is essential for electrical safety and protecting people and property from electrical hazards. Firstly, the grounding system provides a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Secondly, the grounding system helps to stabilize voltage and reduce electrical noise, improving the performance and reliability of electrical equipment. Thirdly, the grounding system helps to protect sensitive electronic equipment from damage caused by surges and other electrical disturbances. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local building department or electrical inspector to determine the specific requirements in your area. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock and other hazards. Always turn off the power before working on electrical circuits, and use appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC and other applicable codes and regulations. They can also help you to identify and correct any electrical problems in your home or business. When hiring an electrician, it is important to check their credentials and make sure that they are licensed and insured. You should also ask for references and check their online reviews to get an idea of their reputation and quality of work. Proper electrical installation and maintenance are essential for ensuring the safety and reliability of electrical systems. By following the NEC and other applicable codes and regulations, and by hiring qualified electricians, you can protect yourself, your family, and your property from electrical hazards. The grounding system is a critical component of any electrical system, and it is important to understand the principles of grounding and bonding to ensure that the system is properly installed and maintained. Grounding and bonding help to minimize the risk of electrical shock, fire, and equipment damage. The NEC provides detailed requirements for grounding and bonding, and it is important to follow these requirements carefully to ensure a safe and effective electrical system. In addition to the NEC, there are other resources available to help you learn about electrical safety and proper electrical practices. These resources include books, articles, websites, and training courses. By taking the time to educate yourself about electrical safety, you can help to protect yourself and others from electrical hazards. Remember, electricity is a powerful force, and it should be treated with respect. Always follow safe electrical practices, and never take risks when working with electricity. If you are not sure how to do something safely, it is best to consult with a qualified electrician. The National Electrical Code serves as the cornerstone for safe electrical installations. It's regularly updated to reflect new technologies and address emerging safety concerns. Familiarizing yourself with its requirements is essential for anyone involved in electrical work, whether you're a homeowner undertaking a small project or a seasoned electrician. Grounding, in particular, is a complex but crucial aspect of electrical systems. It's not just about connecting wires to the earth, it's about creating a safe path for fault currents to flow, minimizing the risk of electrical shock and fire. The methods outlined in the NEC, such as using approved connectors and splices, are designed to ensure that these grounding connections are reliable and effective over time. When selecting connectors for grounding, pay close attention to the markings and listings. Connectors marked for grounding have been specifically tested and approved for this purpose, ensuring that they can withstand the demands of a grounding system. Similarly, listed mechanical splices have undergone rigorous testing to verify their performance and safety. Beyond the specific requirements for connecting ground wires, it's also important to understand the broader principles of grounding and bonding. Bonding, for example, involves connecting metal parts of the electrical system together to create a common ground potential. This helps to prevent voltage differences that could lead to electrical shock. Equipment grounding conductors play a similar role, providing a path for fault currents to return to the source from electrical equipment. These conductors must be properly sized and installed to ensure that they can effectively carry fault current and protect equipment from damage. Regular inspection and maintenance are also essential for ensuring the continued effectiveness of a grounding system. Look for signs of corrosion, damage, or loose connections, and address any issues promptly. Over time, connections can loosen or corrode, compromising the integrity of the grounding system. It's also important to keep up to date with the latest edition of the NEC and any local codes or regulations that may apply to your area. Electrical codes are constantly evolving to reflect new technologies and address emerging safety concerns. By staying informed, you can ensure that your electrical installations meet the latest standards and provide the highest level of safety. In addition to the NEC, there are many other resources available to help you learn about electrical safety and proper electrical practices. These include books, articles, websites, and training courses. Consider taking a course on electrical safety or reading a book on the subject to deepen your understanding of electrical principles and best practices. Remember, electricity is a powerful force, and it should be treated with respect. Always follow safe electrical practices, and never take risks when working with electricity. If you are not sure how to do something safely, it is best to consult with a qualified electrician. The importance of hiring a qualified electrician cannot be overstated. Electrical work can be dangerous, and it's essential to have the expertise and experience of a trained professional. A qualified electrician can ensure that your electrical installations are safe, code compliant, and reliable. When hiring an electrician, check their credentials and make sure that they are licensed and insured. Also, ask for references and check their online reviews to get an idea of their reputation and quality of work. A good electrician will be knowledgeable, professional, and committed to providing safe and reliable service. They will also be able to answer your questions and explain the work that they are doing in a clear and concise manner. By taking the time to find a qualified electrician, you can have peace of mind knowing that your electrical work is in good hands. In conclusion, proper grounding is essential for electrical safety, and the NEC provides specific guidelines for ensuring safe and effective grounding systems. By following these guidelines and hiring qualified electricians, you can protect yourself, your family, and your property from electrical hazards. Remember to stay informed, follow safe practices, and always consult with a professional when in doubt. Electricity is a valuable resource, but it must be treated with respect and handled with care. By taking the necessary precautions, you can enjoy the benefits of electricity safely and responsibly. Electrical safety is not just a matter of compliance, it's a matter of life and death. Taking the time to learn about electrical principles and best practices can make a significant difference in preventing accidents and ensuring the safety of yourself and others. The NEC is a valuable tool for promoting electrical safety, but it's up to each individual to take responsibility for their own safety and the safety of those around them. By working together, we can create a safer electrical environment for everyone.